So let's start with the problem. Context: ASICS is a global sportswear brand that supplies the manufactured trace running shoe to repair sport, one of Australia's leading sporting good retailers. However, this product line faces high seasonal demand fluctuation, especially during marathon season and outdoor running events. The main problem lies in forecasting and accuracy. When ASICS underestimate demand, repair sport experience stock out, meaning less out and unhappy customer. But when they overestimate demand, their excess inventory leading to high storage costs and low efficiency across the supply chain. So the key challenge here is the supply-demand imbalance, mainly caused by limited information sharing and a lack of real-time cooperation between ASICS and retail sport. Therefore, the main objective of this analysis is to improve forecasting accuracy by implementing the collaborating planning, forecasting, and replenishment model or CPFR. This model encourages both partners to share sales data, jointly plan demand, and coordinate replenishment. In short, by applying CPFR, ASIC can reduce forecast error, improve inventory efficiency, and build a more responsive supply chain. To understand this problem in depth, let's look at the theoretical framework behind forecasting and supply chain performance. Analysis is based on four models. The first one is exponential smoothing, a traditional forecasting method that relies on past sales data. The second is SG-Boot, an advanced II model that incorporates multiple external factors. The third one is CPF, or a collaborative model focusing on planning and information sharing partner. The fourth is the SCORE model, a supply chain framework that links forecasting accuracy to performance outcomes like cost and responsiveness. This model contributes a different perspective. Exponential smoothing provides a simple and reliable baseline forecast. SG-Boot adds predictive power by integrating variables such as weather, sport, events, and online trends. CPFRs emphasize collaboration and data transparency between ISIS and repair sport. Finally, the SCORE model have evaluated how better forecasting improve overall supply chain efficiency. Together, this model creates a comprehensive view of how ASIS can combine data analytics and collaboration to enhance both accuracy and agility in its supply chain. Come to the first model, exponential smoothing. This is a traditional forecasting technique that gives more weight to recent sales data while still considering older data. This basic assumption is that future demand will follow past trend. For instance, if sales have been slightly increasing over the past few months, the model smooths this pattern to project future sales. At ISIC, this method is still used for a stable product category where demand remains relatively consistent. For example, standard running shoes or accessory. It's simple, cost-effective, and produce consistent forecasts. However, for manufactured trace running shoe demand fluctuates dramatically, especially during running season or special events. Because of this, the model struggles to capture sudden spike or drop, resulting in inaccurate forecasts. The key limitation of exponential smoothing is that it cannot react quickly to market changes and ignore external influences like weather or sporting events. To overcome this, ASUS has begun to combine traditional methods with AI-driven models like SG-Boot and to implement CPFR for real-time collaboration with repair sport. The hybrid approach allows ASUS to balance stability and flexibility, maintaining reliable baseline forecasts while adapting more dynamically to changing market conditions. This is limitation of traditional forecasting. Next, Yahuin will explain how SG-Boot, an AI-based model, can enhance forecasting accuracy for ASICs.
Hi, I am Huynh. I'll be talking about how ASICs and wearable sport use two advanced methods, attributes forecasting and collaborative planning, forecasting and replenishment, or which we call CPFR, to improve their supply chain performance and meet customer demand more effectively. Now let's start with the attribute forecasting. It's an advanced AI and machine learning model that enhances forecasting precision by analyzing large amount of data from many sources, not just past sales. Unlike traditional forecasting, this method unlike traditional forecasting method that rely purely on historical data, actually would bring in external factors such as weather conditions, sporting event schedule, or online search behavior. Like when outdoor temperature drop or when a major marathon is coming up, the model detects changes in consumer interest, such as more Google searches for running shoes that help ASICS predict demand for products like trail running shoes before sales even happen. By combining all these data inputs, actually can uncover non-linear patterns that traditional time series models often miss. This broader perspective allows ASICS to better understand market behavior and respond quickly to real-world changes. About how it works, attributes use gradient boosting techniques to find hidden relationship between variable and is constantly retrained with new data to stay accurate. Now in Australia, it can detect higher demand in state hosting outdoor events, allowing ASICs to adjust production and distribution accordingly. Industry study also show that AI-based model like XGBoost can improve forecasting accuracy from 10 to 30%. Depending on the data quality, this means fewer stock out, less overstock, and quicker response to market shift, which gives ASIC more flexibility in production and inventory planning. Now let's go to the CPFR part. This framework was first introduced by the VICS Association in 1988. It is used to improve supply chain efficiency through real-time communication and joint decision-making between partners, and in our case, it's obviously ASICS and RoboSport. CPFR operates in three continuous phases: collaborative planning, collaborative forecasting, and collaborative replenishment. In planning, both companies align proportional calendar and product launches, or in forecasting phase, they share markets and sell data to develop more accurate forecasts. And finally, in replenishment, ASICs adjust productions and delivery schedule based on RoboSport actual sale. This structural process makes sure errors are detected early and stock levels stay balanced. In practice, ASICs and RoboSport can implement CPFR through a shared ERP platform to synchronize data like sale record and inventory level. They might also hold joint forecasting meeting every 3 months and use weekly retail report to refine production plan in real time. The benefits are significant. It reduces information gap, improves forecast accuracy, cutting costs, and ensure products are always available when demand peak, especially for popular items like the Meta Fuji trail running shoes. However, there are still some challenges, such as delay in data update, system incompatibility between XGBoost and RoboSport software, and differences in performance metrics. Overcoming this issue through stronger digital integration will make the CPFR process even more effective. So by combining AI-driven forecasting and collaborative supply chain practice, ASICS and RoboSport can build a more reliable and responsive supply chain. This will transform their partnership from a simple transactional partnership into a strategic collaboration based on data transparency and mutual benefit. And so now we can go to the next part with Anne.
ASICS and Rebel use a collaborative system that combines AI-powered forecasting with real-time data sharing. So first, data integration. Rebel provides live sales data, promotional calendars, and key seasonal events. And ASICS feeds this into its XGBoost model, along with weather and train data. And data is exchanged through electronic data interchange, which is EDI, enabling a single aligned data source for both parties. And second, the planning cycle. Both companies run quarterly CPFR meetings to review forecast accuracy, plan upcoming seasons, and align inventory targets. This allows ASICS to synchronize production with expected demand. And third, replenishment and logistics. So replenishment is highly responsive. Rebel's automated system adjusts store stock based on real-time sales, and ASICS supports this with sea freight for base stock and air freight for urgent replenishment through global 3PL partners. And as a result, this collaboration has significantly improved forecast accuracy, reduced stockout during peak season, and created smoother replenishment cycles between ASICS distribution center and Rebel stores. However, several integration gaps still hold the system back from reaching its full potential. Forecasts are still updated monthly, reducing agility when weather or event change occurred. And the two systems are not fully integrated and still rely on manual uploads, which create delays and inconsistencies in shared data. And manual revision remain common. Each time a forecast is corrected, it adds processing time and increases lead times, and it slows down the replenishment. And there's also no shared KPIs dashboard, meaning each business measures performance differently, and without common metrics, collaboration becomes harder to quantify. Compared to industry leaders, there is room to advance. Nike, for example, they apply AI and machine learning across their global supply chain to forecast demand and automate replenishment. And by combining real-time sales and store data, Nike has improved forecasting precision and delivery reliability. And similarly, Decathlon integrates RFID, EDI, and AI into a real-time CPFR system that balances efficiency with sustainability. And these benchmarks shows that real-time automation is now a strategic requirement. And with deeper system integration and shared KPIs, ASICS can shift from periodic collaboration into a predictive, self-optimizing value chain. So overall, ASICS and Rebel have made strong progress, but full integration is the key to unlocking the next level. And next, we're going to move to our summary and recommendations.
After analyzing the benchmark of ASICS company by giving some global practices, we'll move to the next part, the summary of findings. First of all, the forecasting and CPFR improved accuracy significantly. It improved forecast accuracy through combined AI modeling and CPFR data sharing. We have more responsive replenishment, leading to reduced stockouts during peak seasons, and and it improves stronger partner alignment with Rebel Sport. However, we have the negative news about this model is that the integration gaps remain. The forecast latency, many update cycles are too slow. System fragmentation because AI and retail data is separate silos. The misalignment performance metrics because they have different KPIs. However, we have the opportunity for full automation and shared performance tools. Closing the technology and data integration gap is critical next steps that unlocks the next level of supply chain efficiency and resilience. This alignment links directly to our strategy recommendation. To achieve this purpose, we have four main recommendations for ASUS company. First of all, they should implement a fully AI-integrated CPFR platform. ASUS and Rebel Sport should develop an AI-enhanced CPFR system. This platform could integrate more company sales, forecasting, and inventory data in real time. By connecting ASUS machine learning models directly with Rebel Sport database, we can achieve clearly that data visibility and faster response to market fluctuations. Secondly, increase forecast update frequency. We must transition from monthly or quarterly cycles to weekly forecast updates. This cycle enhance agility and accuracy, allowing both organizations to rapidly adjust to shifts in sales trends, weather patterns, or promotional events, thereby reducing stock imbalances and lost sales. Thirdly, they should develop a set KPI dashboard. A joint performance monitoring dashboard is essential. We target critically metrics like forecast accuracy, stock count rates, and inventory turnover. Using the same data visualization tools ensures a consistent, transparent framework forecasting, fostering accountability, trust, and continuously improvement. Lastly, they conduct joint forecasting and data analysis training. Cross-organizational training workshop will enable teams on forecasting methodologies and data integration. This promotes a collaborative culture and ensures staff can effectively use new AI models, AI tools, reducing the risk of human error or bias.